Hey everyone, I'm Marcelo. Thanks for joining us today. Um, as you know, I'm a big fan of AWS, but it can get messy. The settings are spread everywhere, like hundreds of little pieces, and it makes security tough. In this webinar, we are going to go over simple ways to keep your AWS account safe. We'll go over permissions, managing your team, and setting up solutions the right way. Also, Will is going to show you a tool that can help you doing this in a faster way. This is perfect for managers who take care about safety or tech folks working in the cloud. So there's something for all of you. So Will, let's jump in.
Thank you, Marce. Welcome everyone, and thank you for joining us today. I'm going to share my screen. All right, so in this webinar, we will be exploring at different strategies that will help us get a better sense of security when using our AWS account, as Marcelo was saying. We will cover security good practices around the use of the account, permissions, and the management of the staff, as well as good practices when mounting new solutions from a data and communication point of view. So our agenda today will cover a few different things. We'll start by talking about the security design pillars in AWS that are driven by the well-architected framework. Then we will move into some essential good practices, looking at some standard services that can be used to protect our setup. Next, we will cover the security from an architectural point of view when drafting new solutions. And finally, we'll do a quick demo of our free security tool that we just launched that will help you get a first assessment of your cloud architecture. All right, so a good place to start is by going through the security pillar design principles within the well-architected framework. And by the way, the well-architected framework is a best practice guide and is composed of a different set of blocks. So these pillars represent different aspects of an architecture as we see it, and they are split into different concepts, which are operations, security, reliability, performance, cost, and sustainability. So with each of these pillars, we have a number of design principles, which really you should see as architectural goals, let's call it, right? So you seek to achieve those goals within your own architectures. So let's now do a deep dive into the security pillar specifically and describe what are some of the best practices there. And we can say that it is really important that you start with your strong identity foundation. So you have all your identities in one place to easily manage and reduce that security risk. Then traceability is about monitoring and logging that you need to set up at all layers of your application. So having that visibility of knowing what's going on with your application. The next is applying security to all layers, which is a defense approach. So starting with your application on your outer edge, all the way through to secure coding practices. And you should try to automate all of these things as much as possible. For example, using infrastructure as code, templates, which is going to save you certainly a lot of time. Then it is important to secure your data at rest and in transit. And typically this comes down to encrypting all the data and providing that protection for your customers and administrators. And finally, it is also important to be prepared for a security incident. And this involves being aware of what you need to do, who you need to reach out to during these security events, and being prepared for it in the first place by running simulations and having runbooks and playbooks in place. Okay, so we are going to start with a strong identity. And for this, it is important that to be able to rely on a centralized identity to ensure that we have control access to our architecture. It is recommended that we work with a service called Identity Center to manage external users, mainly when working with large accounts, maybe multiple departments. But for small teams, using the Identity Access Manager, which is a much common service, is also usually a good fit. But as we build up our staff and the need to provide access to maybe 1,000 accounts, we'll need services like AWS organizations and Control Tower to orchestrate the federation and the access of those accounts, and they need to have a single sign-on service, right? So we need that sense of organization there. And a simple but very important recommendation is to make sure you use strong credentials to enable MFA for all of those accounts. So then once we have those accounts in place, we should follow a least privilege model. And this means that not all users will need access to the same things. So we should provide visibility and access to only those things that those users are working on. And the last item about auditing credentials refers to the ability of controlling those credentials over time. So once people leave, for example, an organization, we should revoke that access to have a healthy control of our account. So while that covers the concept of identity for humans, there's another important topic around identity, which is for services. And services should be treated differently, as they should work with temporary credentials. You can see it in the diagram below, that we got a role attached to the instances, the RDS service, and the Lambda function. So these roles are going to enable us to get ephemeral tokens from the token service. And that means that we don't have to hard code or anything, access keys or secret keys or any of those in your code. And you will certainly find a lot of coding examples in the internet that when they use the AWS SDK, they use these pair of keys to connect to the different resources, right? So from, for example, reading from a database or connect to the internet. But what you should be doing instead is to communicate services through roles attached to those services. So now we move on to enabling detection. And this is really the ability to configure services and also our application to log, ideally, to a centralized point where we can automate in terms of creation of alarms according to the information that's coming in. So these services will provide insights of our account and will become very valuable as our list of resources grow. For example, CloudTrade keeps record of every action within our account that is made by people or services. So this is a good place to have a first look at what's going on when we need to troubleshoot a particular problem. Then GuardDuty and Security Hub will help us discover threats and vulnerabilities across our fleet. And AWS config will help us to commit with certain compliance definitions And these compliance definitions can be things like to ensure that all of our buckets are encrypted, that all of our EBS volumes have certain type, and maybe that ports are closed at certain ranges and things like that. So we can be ahead of those security checks with things like Confi. And once we enable these type of services, we want to manage the historical findings and logs centrally, and that's where we have a log archive target. So this log is, an isolated place to keep the record. So if something bad happens or if we make a mistake, which is a pretty common thing to happen, then we have those logs that are essentially stored, for example, in S3. So while that help us get detection at the account level, we still need to get better insights at the application level. And what that means is that we should have monitoring in place for our application. It is important that we always consider running our apps within a private subnet inside a VPC. So the access to the internet and to the services is enabled only when needed, and the communication between our software, either whether it's running in EC2 or Lambda, is secured by this network layer. So VPCs will generate logs for the access to the network, and those logs, as well as the application logs, can be stored in CloudWatch. And we can use CloudWatch to search through those logs and build custom dashboards and metrics that we can use to debug our application, but also to troubleshoot these security problems. Okay, so let's continue this idea of extending our security to the different layers of our application, and let's have a look at the following diagram. So this is what we can call a defense in depth approach, and what this means is that we don't rely on a single layer for our security. We apply security at multiple layers. And we are going to create these network layers. So before we even reach our workload itself, that we can imagine is at the right side, our VPC, we perform checks when we get traffic that it comes through Route 53 and then into CloudFront and then into WAF. And WAF here is an essential security service that will allow us to define firewall rules to access our network. So we can protect from some common attacks, filter certain IPs, and pass on only requests that went through that validation. So this is beneficial for performance, security, and consumption of resources. So as we build this out, we can see that we got our network layers here. So our public layer at the top, typically with a load balancer. Then following that, we'll have a shared layer. And that shared layer is going to be egress only. So again, another layer of security there. Then we have the application layer. And finally, we'll have our database layer running ideally in a private network. So how are we going to control traffic to all of those different layers is with a number of things. We have security groups that a lot of you will be familiar with, but also network access control lists and also root tables at a network layer. And those will ensure that we got appropriate protection. They can also make sure like root tables are applicable to that particular layer. So for example, we need to make sure that the database layer can talk to the application layer, but not necessarily to the public layer. So we keep that communication also close between the different layers. So this more or less builds our principle of controlling traffic at multiple layers. And this becomes now a bit more complex. So as we move forward with the example, we can make use of some additional security-related services. If you look towards the left and the bottom side of the diagram, you can see Secrets Manager there. So using Secrets Manager, in this case, to perform automatic rotation of the passwords that are being used for RDS. So we don't need to do that by hand or be on top of those passwords or keep copy and paste them. So all of that is taken care by the automatic rotation of Systems Manager. So every periodic cycle, those RDS passwords will be automatically rotated. And again, these credentials are secure with secure encryption through KMS. And we have also introduced CloudFormation here. And while this is a service to create infrastructure as a code, that will also be a way to allow consistency and readability of our architecture, and also to have drift detection. So if we make manual changes to our resources, CloudFormation can help us to detect that. So it's also another extra way to have a security measure. So it also saves a lot of time. We need to replicate certain environment that we work with. We can easily copy that and create new environments for our development. And following this idea of automation for security, we can build different pipelines and imagine that we are using containers or images. So we can use services like Systems Manager to automate the process of building improved images and the patching of our instances and to allow secure command line execution, for example, in EC2. And another service that appears in this combination is also Amazon Inspector, that will help us to automate the findings of vulnerabilities across our EC2 instances and also container images. So Inspector will get you a dashboard with findings in the instances about packages outdated or new things that are being updated elsewhere. So you get a sense of what things you need to update with your images and your instances software. So by enabling all of these things, we can ensure that we are up to date with security findings and also how to reduce our attack surface. Okay, so we'll move now on to the protection of data. And here we should be looking at first at data in transit, which means enabling HTTPS and secure communications between users and our applications. And then also enforcing encryption of data at rest to make sure that when we store data, we are encrypting as much as possible. And that can be S3, a database, a volume, and so on. But if we talk about S3, then we should consider using a service like Amazon Macie. So Macie essentially allows us to scan S3 buckets for identifying sensitive information. So it could be things like credit card numbers, personally identifiable information that we shouldn't be storing there, right? So, or we don't need to store. So Amazon Macie will help us to go over that data that can be in the form of different file types and help us identify these type of things. Then we can move and perhaps allocate different policies to those files or maybe move them elsewhere and treat them differently, right? So then we also have KMS, which we mentioned in the previous slides, and this service integrates with many other things in AWS, and will allow us to enable encryption, for example, across our instances, our volumes, and in the S3 data itself. So it's a great way and a great tool that we can enable everywhere with just a few clicks, and add that extra layer of protection of data encryption at rest. Then for in transit, take a web application. So in transit, we want to be doing things like TLS or HTTPS certificates. And the certificate manager will give us no-cost certificates with automatic rotation built in. So we can tie that into CloudFront, for example, or even the application load balancer, and make sure the data is also protected during communication, even for our test and internal applications. Our last design principle is about preparing for security events, and this is really important aspect when looking at the security, because in the first place we should make sure that when we actually do get a security event, the tools and the access are already in place, right? For those that who need to investigate, everything is ready. And to get to that point, it is important making sure that you run regular events on simulations, and this is a way to really become smoother dealing with security events. Ideally, you shouldn't be experiencing them for the first time during a production outage or event. So the recommendation here is to make sure that you run these simulations, perhaps with your team periodically. So AWS has some services that will help us organize these simulations. We have Incident Manager as a way to prepare a plan for the incidents, have contacts in place, procedures, and action items. So it's a good way to organize that information in a centralized place. And then from a more technical perspective, we have the fault injection service, which will help us build scenarios of potential issues that can be services going down, network disruption. You can play with the memory capacity of your resources and so on, right? So it's also a nice technical way to prepare for those disaster events. And a part of these tools, I also tend to recommend trying to build your own scenarios and work with your team. So describing, for example, a scenario of an issue. That can be something like, I know that the credentials of a developer are suspect to be leaked. Your team needs to be on top of it, investigate, contain, and probably recover from that breach. And that is when you can make actual use of the tools like GuardDuty, CloudWatch, System Manager, maybe to automate remediation rule, and AWS config to be on top of that for the next time. So these type of things will give you the experience you need to deal with these different scenarios. Okay, so so far we covered many different things and services, and we know that if you are not familiar with the daily operation of your architecture, it can be very hard to have a trace of all the things happening. And this is something that we have experienced with some of our customers. So we wanted to help these type of users with a way to quickly provide them with an overview of the security incidents that may need attention on their account, without the need for going into each one of those security services and check what's going on. So with this in mind, we came out with a small product that we are about to publish in the marketplace, and we call it the Security Auditor. So this is essentially a container image product that can be installed using CloudFormation and we create in minutes a report for you with all the security vulnerabilities and findings in your account, so you can then take action on those as needed, right? So let's now do a quick demo of this tool, and I'll try to give you a quick overview on how to use it if you maybe haven't used the marketplace before. So this is the link to the product. Marcelo will share it or chat. Okay. So once you access the product or the marketplace, this is so small. The first time you need to buy the product. Is actually free. It's just something you need to do, but it's full free. And then you get to this point, you can view the different options for it. You will have a description. Go ahead and read it, and once you're ready, you can continue to the configuration. You can here select a version of the product. There's just one single version, and you can just move to the next step. And you'll get to the point of launching this image. And here you have a few different options. You can install this image on your own using any of the image supported services, ECS, EKS, or even locally if you want. And you can follow these usage instructions to do it yourself. But more easily than that is to use the provided CloudFormation template. And the CloudFormation template has everything that it needs in place to run the auditor and get you a report about the findings. So the only thing you need to do is just to provide recipient email where you want to get a report, right? And that's it. You just acknowledge and create a stack. And CloudFormations, for those that are not that familiar with, it's infrastructure as a code services. So we'll essentially automate the creation of a few different things that will take action on your behalf. In this case, it will go to each one of those security services that we just talked about, get a report of those, create an HTML output, and just send that over email, right? So it's a really easy way to get an overview. And this takes some time to create a few different things. But when it's ready, you should be receiving an email in your inbox with a link to the report. Check your spam folder just in case. And the result will be something like this report. And this is an example of what the tool does in one of the accounts. So it has findings of different severity. For example, things that are uncommon or are suspicious of malicious attacks. In terms of the usage of keys, this can be done because of people or because of services. Then we got to lower priority things, maybe some brute force attacks that will make you think that if you need to close some ports or add some network maybe checks on top of it, like some of the things we've been discussing about. And this is about the resource findings. And then we have other threats in general that are more related to libraries and software. So these are findings, for example, in container image or EC2 instances. So also sorted by the different severities, and will get you a sense of how many things you might need to pay attention to. And there's also an analysis over the access or suspicious access of some roles and identities on your resources. And finally, you get to a credential report of your users. I will say that the most important thing here is that make sure that everyone has MFA enabled and that your passwords are rotated ideally more frequently. So this will help you get in just a few minutes a report of your account if you're not that familiar with all of those services. So again, Marcelo will share the details of the product. You can just install it on your account, get that report. If you have any issues, don't hesitate to contact us. That's pretty much it about the presentation. As a quick recap, we have discussed across the webinar different security strategies. We had a look first at the security pillars, then we went through the different aspects of security, starting with identity for humans, then for services, then operations, building architectures, then the importance of security on the data. And as we move forward, we mentioned quite a few services that can help you get to a better security standpoint. So hopefully this gets you to a more aware and efficient position in regards to security in the cloud. So yeah, Marce, over to you if you have any questions from the audience.
Yeah, let me check. I think we have a couple of questions. Okay, we have one from George. He says, I'm a small business owner with just a few employees. Do I really need to use services like AWS organizations and Control Tower?
Okay, yeah, so I would say that for the small businesses with just a handful of employees, the identity access manager service, it's good enough to manage your account securely. It will allow you to create users, set permissions, enable MFA. We'll cover the security needs you might have for now. And those other services can be enabled at any point in time. So if your amount of accounts grow, you can always start using organizations and Control Tower at a later point. Maybe organize those users into departments and have a more controlled set of things for permissions, security, cost. So yeah, it's good enough to use just the identity access manager service for now.
Great. So yeah, we have some more questions, but we have time for one more. Let's take this one from Mark. The security auditor tool sounds helpful, but how do I know it is safe to install in my account? What exactly does it check for? Okay, you mentioned a lot of what it checks for, but can you please address the question about how safe it is to install?
Okay, good question. Yeah, so the service is essentially a container Docker image. You can actually inspect at the code if needed, but the important thing is that it runs in a secure and isolated environment under your own account. So it will essentially have permissions to only read your information, produce that report with your data, and just get over that to you. Yeah, it just aggregates findings, and the CloudFormation template is also built to get to that image only the permissions, the reading permissions that it needs to get aggregated data from all of those services within config, security hub, and some others, and build that over to you and just put it into an S3 bucket that you can also check if you didn't get the report via email. So yeah.
Okay, great. So thanks, Will. Your presentation was great. It was very clear as always. So I hope everyone in the audience picked up some good ideas to keep the AWS account safe. So thanks everyone for joining us. If you want help making things even more secure, you can reach out to us for a free consultation. I dropped in the chat the link so you can grab a stop. So yeah, just contact us and we will figure it out together. So see you next time.